It is with great pleasure to introduce to you our speaker today, Jonathan Yewdell. Jonathan is the chief biologist at one of the sections at NIAID, Institute for Allergy and Infectious Disease. He is also of an Ivy League training platform, some Princeton or something.
Penn, Brown.
Brown, but
Sorry.
An honorific Brown.
Honorific. I have a brown sweatshirt.
He is coming over.
Proudly wear.
Even a shirt, yes?
Not yet. You can buy me a shirt.
Okay.
I won't send it
That's
back.
An interesting hint.
Yeah, exactly.
We'll do this.
I was looking.
So after UPenn, then Imperial College London, then NIH.
Wistar Institute. I was
Wistar
a professor for 4 years.
Oh. And then NIH, where he is now one of the leading immunologists, and we're delighted to have him here. I remember with pleasure our work together on our paper, where we fought a little bit with the proceedings of the National Academy of Sciences to accept the longest title in the longest word in the title of the paper. Our paper was titled Comparative Immunopeptidomics, spelled in one word, of human and their pathogens. So,
great title.
Thank you for coming back. Brings back great memories, and I cannot find a better speaker that will kick off our new lecture series, the Grantsmanship lecture series.
Yeah, I told Soren this is tremendously ironic since we don't write grants.
So he said that it looks like a Seinfeld joke to pick the person that is less qualified, but I think on the contrary, we cannot have a better speaker for this title.
Well, maybe.
Let's thank Professor.
I also got promoted.
Didn't you say academia?
I'm promoted to professorship, exactly. Okay. So the title of the talk is How to Succeed in Science Without Really Trying. And I'll just tell you, for those who don't know, I've written a few essays based on this talk that you can find in Nature Reviews in Molecular and Cell Biology. So if you can't download them, just email me. I'll send them to you. It's basically the more important points that I'm making today, and also some really outstanding cartoons. Not that I drew, but a friend of mine who was a postdoc at NIH named Alex Dent, who has a website where he's got these cartoons, and they're really brilliant, and they put into pictures, you know, way more than 1,000 words, what it's like to do science. So 2 of these essays, please take a look at them. And I'll just tell you that unlike this guy, God does not speak through me. What I'm telling you is my opinion about how to succeed in science. So take it with a grain of salt. You know, as the new senator would from Minnesota would advise you. This talk came about because I think 8 years ago now, the students in University of Nebraska invited me to give a keynote talk at the Midwestern Symposium on Science, Biomedical Science, something or other. And I thought I would give them, say, 15 minutes of advice, career advice, because when I was a student, you really didn't have to have any career advice. No one ever told us anything. You didn't need much. If you had a relatively normal IQ and you weren't completely psychotic, you basically got a chance to run your own lab. It was a much, much less competitive time. For you guys, that isn't true anymore, sadly. Science has become incredibly competitive. And so I put down what I thought was 15 minutes of advice. It turned out to be about 30 minutes of advice. And the talk was received reasonably well. And so I turned it into an hour talk. And I don't know, you guys are probably about the 60th group I've given it to. It's a talk I really like to give. And I don't mean to offend anybody. Please, when you get advice, you know, you take what's useful. And the other stuff, forget about it. And some of the things you don't agree with me, just say, you know, guy's full of shit, whatever. Okay? So, how to succeed in science without really trying. It actually comes from a Broadway show. the title of which is How to Succeed in Business Without Really Trying. Here's the Internet Review, a light yet scathing musical satire about a young man trying to make it in the business world. It's true. This was a movie. It was a Broadway show. First it was a Broadway show, then a movie, and then a Broadway show again. This is Matthew Broderick in the starring role, and it is a cynical story. It's a guy who starts out at a company as a window washer, and first day on the job he finds this book which says how to succeed in business without really trying. And, the book gives him some advice, like show up 10 minutes before the boss, mess up your desk and your clothes, make believe you spent the night in the office working hard. You do this in the lab, it'll work. Soren comes in, sees you there, flattened out in front of your computer screen, he's going to be impressed. This guy's a hard worker. You pretend you went to the same Ivy League university as your boss, and you learn the fight song. This is, it's not playing. I have Fight on Pennsylvania. So that's the idea. Very cynical way of working your way up the ladder, where you don't have to actually know anything or do anything. Just kiss the right ass. So this is a New Yorker cartoon, one of many I'll show you. This is fine as far as it goes. From here on, it's who you know. So is that true in science? As it is in business, or at least as cynically it is in business? Is that really true? Can you succeed in science without really trying? Well, even first-year graduate students probably know that this is not true. You can't succeed in science without really trying. I thought it would be obvious to the entire world that this title was a joke. I gave this talk in Germany a couple of years ago, and apparently not all the Germans got the joke, because one of the guys said, it was a good talk, but I admit I was disappointed. I said, why? He goes, I thought you were going to tell me, how you succeed without trying, and you told me the opposite. I said, I thought that was pretty obvious. So, in fact, if you were trying to pick the career that was the most difficult, that paid the least amount of money, you found it, right? Science is a very challenging career. And don't kid yourself. If you think, boy, once I'm a postdoc, it won't be so challenging, or once I get to be an assistant professor, it won't be so challenging, or once I get tenure, I'll have it made. No, it's not true. Your whole career, it's going to be extremely demanding, particularly if you stay in laboratory research and you run your own group and you fund your own group. You're looking at an entire career of constant challenge, right? And in the end, the pay isn't so bad. But you can do a lot better taking your talents and work ethic and doing something else if it's only about money. Okay? I mean, you really can. To do science, it takes something else. And so we're going to start talking about these philosophical issues. So the most important thing to me, why this is not just complete insanity for you to even contemplate a career in science, is the most important thing about science is to really love what you're doing. You have to love science for it to be worth the effort it's going to take. What does this mean? To me, what this really means is that you have to be one of these people who is just insatiably curious. If you have kids, or you will, or remembering back to when you were a kid, you just want to know. How does that bus work? How does this work? What does this do? How does that TV work? Why do we do things this way? Questioning, questioning, questioning. This is really what it takes to be happy as a scientist. You want to know the answer. And I put the answer in quotes for reasons we'll talk about later. And at the end of the day, it's great to make discoveries, right? But I'll tell you, you make a discovery, and at first when you discover it, it looks perfect. And you have found the answer to the question. And then you realize with time, sometimes a night, sometimes a week, sometimes years, discovery wasn't so great after all. There's all these flaws to it. And at the end of the day, it turns out, after thinking about doing this for 30 years, it's not the discovery themselves that actually is the fun. It's actually the process. It's chasing the rabbit rather than catching the rabbit. It's pursuing the truth. You never catch the truth. It's pursuing it. You have to love that process. It's actually the process of not making the discovery you have to love. The fact that you're always chasing after the truth, that you're actively engaged. If you don't believe me, here's what Einstein had to say about this. He's talking to Freud here. The state of mind which enables a man to do work of this kind is akin to that of the religious worshiper or the lover. The daily effort comes from no deliberate intention or program, but straight from the heart. Okay, important part here. The daily effort comes from no deliberate intention or program straight from the heart. So what I want to tell you is you've got to work your ass off to be successful in science. You're really going to have to put in 50, 60 or more hours per week. Man, that's a lot of work compared to the average person. The trick is it can't seem like work to you. It really shouldn't seem like work. It should be like, man, that's what I want to do. It's not work. I mean, they let me come to the lab. If you're going to be happy in science, that really is your base attitude, right? You want to be there. At your stage in life, you're not married, you don't have kids, what else do you have to do anyway? I'm serious about this. You think I'm kidding? I'm not. You really should want to be in the lab. And if you don't, there's nothing wrong with you. You're normal. Okay, I'm not telling you in the end of the day that scientists are average, well-balanced people. Look around at your professors, right? We're not. Right? I'm not telling you should be normal or well-balanced or anything else to be a scientist. It actually takes a degree of obsession that probably is not healthy. But that's what it takes. And if you don't have that, no one makes you do science. You don't have to do it. You could take your talents and do anything else. And you won't be a failure in any sense of the word. Right? But if you're going to be happy doing science, you really got to want it. Again, it's got to seem like not work to you. At the end of the day, honoring the scientific method is way more important anyway than any discoveries that you and I will ever make. To me, the ends never justify the means in science because, among other things, there's not one of us in this room who is so smart or special or insightful that if you weren't born, someone else wouldn't discover it. Right? Maybe in physics it's that way. Even there, I doubt it. But in biology, absolutely not. The discoveries are there for the making. Smart people will get there quicker, but sooner or later, people will get there. Right? So don't go into science to save the world. Bad motivation. We know people like this. They're painful to be around. The world depends on them. Often they have long white coats and it says Dr. So-and-so. Right? Right? Often MDs. Not always. Often. Someone else will cure cancer. Okay? In fact, even if you're wildly successful, I have one of these charts on the wall to remind me every day, right? Each of these charts, right? All these lines, this is just intermediary metabolism. Each of these little pathways, it's probably, 50 papers, people fighting with each other. Who gets credit for it, who discovered it? Is the paper going to be accepted or rejected? At the end of the day, what does it boil down to? It's a line or two, or, if you're very famous, 10. Of the giant chart of life that, basically, if you're lucky, future students will just resent memorizing. That's what it boils down to. All these things we're so engaged with are interesting now. To future generations, they'll be, yeah, I know that. That's boring. Right? Someone discovered that. Right? And even then, you put the charts you put the lines on the chart of life, and your job is actually to show how everything is wrong, not how it's right. Ideally, you'll show, no, this isn't exactly right, and this isn't exactly right. So you can spend your whole life as a scientist doing everything perfectly. I mean perfectly. Being really smart and insightful. Doing everything right. And at the end of the day, it turns out it's all completely wrong. You may have misled your field for 50 years for all you know. It just happens. Right? Just because all the assumptions were wrong. Okay. At the end of the day, it really doesn't matter if you have honored the scientific method. Right? And in any event, striving to achieve fame as a scientist is futile exercise. Right? Can you name the Nobel laureates in medicine and physiology over the last decade? I can't. My own field, chemistry, one. So this is this is our fate as scientists, or anything else for that matter. Shouldn't he have a bigger monument? After all, he did invent fire on the wheel. Guarantee you, before you retire, people will have completely forgotten what you've done. Completely. No one cares. It doesn't really matter, actually. Ego is a part of science, but at the end of the day, humanity makes the discoveries. Soren doesn't make them. I don't make them. We get credit for it, but no one really cares at the end of the day. Even if you're the world's most famous scientist. No one really knows or cares. What is science? In the end, despite the Nobel Prizes and the star system of contemporary science, what it basically is a communal exercise. The most communal exercise ever invented by man is what modern science is. And what are we? We are basically ants in this giant international scientific colony. right? And what do we do as ants? You know, we make discoveries, right? We publish papers, which is basically what ants do. They bring food back to the colony. That's what discoveries are for us. What publishing paper is. And if you really want to be happy as a scientist, that has to be enough. Just the process of making the discoveries, interacting with people, being part of the colony. That's what makes a happy scientist. If you're in it for the ego gratification that people should tell you every day how smart you are, you will not be happy. And you will make everybody around you miserable. Guaranteed. You should not take this international nature of science for granted. It is an amazing thing. I look around the room, I see faces from all over the world. My own lab, right? It's like a mini Star Trek. People from here and from here and from here. It's an amazing thing, actually. You know, tell me another career like that, right? There are very few careers like that. I have a friend from Romania. I mean, how did we ever meet? It's amazing. And you know people, once you've been in science for 10 years even, you know people from around the world. You can get off a plane anywhere in the world and have somebody you're friendly with without ever having met them because you've read each other's papers. This is an incredible thing. Right? It actually is a force for world peace and understanding. Nations that collaborate are much less likely to hurl nuclear weapons at each other, which brings us to our kumbaya moment. So please link arms with the person next to you and join me in singing Kumbaya, my Lord. That's a joke. You're allowed to laugh. No one's laughing, you know? I think I'm reasonably funny, so you're allowed to laugh. I once gave this talk, actually it was a scientific talk. I had some really good jokes, and the guy says, you know, man, I was killing myself not to laugh during the talk. I go, well, why? You know, I'm not supposed to laugh. Okay. I'm really trying to inspire you in this part of the talk. You know, I'm telling you what a crappy career it is, you know, from the practical aspects, but all the other things are great. Okay? And you may think, does this guy believe this stuff? I really believe this heart and soul. I believe that what we're training you to be is an important member of a noble enterprise that began in the Renaissance. You should not take the scientific method for granted. It is an amazing thing. The scientific method gives us the tools that we need to learn about nature. Testing nature, hypothesis-driven research. Armed with this method, we can find out everything about nature the human mind is capable of understanding. And not only that, I think it's no coincidence that when the scientific method was really formulated in the Renaissance in Europe, people really started thinking about how countries should be governed. The same rules that govern science really should govern how societies make decisions. Right? And we had 8 years of seeing what it's like when we govern ourselves by faith instead of by evidence. And we see where that led us, right? So very important, the scientific method. And you may think we're training you to be a computational biologist or a microbiologist or molecular biologist, but that isn't really true. What we're training you to be is a high priest in scientific Methodism. That's really what we're training you to be. Right? That's my religion, basically. And, you know, I'm a liberal-leaning person, but I'll tell you, the right is an obvious threat. The O'Reillys of the world, and worse, is an obvious threat to scientific progress, but the left is no less a threat, actually, and in many ways more of a threat. People who think that nature is good and benevolent and human beings are bad. This is not the way it is. Science and technology is the basis for modern society. We have 6 billion people on this planet and growing, and the future well-being of all these people depend on you guys. You are the most important members of society by far. Society is going to depend in every way on the discoveries that you guys make. We don't treat you like that, I know. We certainly don't pay you like that, but it is nonetheless true. So if you're looking for a way to spend your talents in the most beneficial way possible for society, science is the way to do it. And I commend you. And no one ever tells us this, but this is really true, and I believe this heart and soul. Okay? Crappy career, true. In terms of the monetary rewards and how hard it is, but in terms of your value to society, you couldn't pick anything better. You really couldn't. Our most important job at the end of the day is not what we discover, but it's passing the torch of the scientific method, right? It's using these tools to learn about nature and then teaching you guys to use it. That's my most important job, is to train you. Your most important job, train the next generation, and so on and so forth. So no matter what we discover, you know, the truth in the end will emerge. It doesn't really matter what we discover as long as we've done it right. The problem with taking shortcuts, even if you get to the right answer, is you now, you cast doubt on the integrity of scientists and the scientific method, and this is never worth what benefits you might accrue from that. Never. We have to maintain public faith in the scientific method because we require them to give us the money to pursue science. Okay? People aren't smart enough to realize that they need to fund science. We have to always convince them why it's important, another part of your job. So most important thing is passing the torch. Okay, so I don't want to sound too negative. And I gave this talk in Singapore last year, and they said, boy, the negative really came through, so list the advantages. So I will. Okay, so there's number one. Part joke. Freedom. Yeah, sure, you have to sell your soul to write grants, but no boss tells you what to do as a scientist, once you have your own group anyway. And if it's a good lab, the PA doesn't tell you what to do either. Let you be. So a lot of freedom as a scientist. If you got a bit of an ego, this is the one place where you can show the world just how smart you are, where you're rewarded for it and not penalized for it like you are in a lot of fields, like medicine. There's a never-ending challenge. You are always challenged. Are there any MD Ph.D.s here? Any? Zero. Okay. The learning never stops in science, another great thing. And, you get a free degree, basically, which isn't bad. Particularly someone who has 4 children, I can tell you, free graduate degree looks pretty good from the father's standpoint. See the world, join the Navy, become a scientist, but you will see the world either way. And friendship, again, these international friendships you make, they're priceless, really. Okay, going to get more practical here. So some of you are experimentalists, right? Are some of them experimentalists? They're not all computational people, right? Well, if you are, bear with me. And this is true for either case. You want to be the bee in science. What does that mean? Cross-pollination between fields pays huge dividends. Huge dividends. Things that are standard in one field, not standard in another field. You can make a career just by carrying ideas between the fields, not even having a new idea. Just pollinating will lead to discoveries, guaranteed. Okay, so how do you do this? Well, go to seminars in other fields. Sit in the back. Crappy, walk out. Right? Talk to your colleagues, talk to your colleagues, talk to your colleagues. What are you doing? What are you doing? Very important, these talking to colleagues. Right? Every time you explain what you're doing to somebody, A, you can get good feedback. B, you teach it to yourself. Okay? Because you have to explain to somebody else. And then you realize the flaws in your arguments, just explaining it to somebody. Collaborate, crucial. As I was talking about earlier today, really crucial to collaborate with people. Many, many techniques, impossible to be an expert in all of them. Read widely, but not necessarily deeply, right? So this is for immunologists. And in fact, when you're starting a project, too much knowledge about what you're doing can be counterproductive. Many, many great discoveries were made by naive individuals who did an experiment that everybody knew wouldn't work, and, it worked. Okay, so, here's the deal. You have a great idea for an experiment. You walk into the PI's office. You can't wait. You had it last night. You just couldn't wait to wake up in the morning. You go in the office. You explain the experiment, and they look at you. And halfway through it, you see this. First they're excited, and you see the smile, and then halfway through it, you see, oh, man, they're disappointed. And then they like you, and they try not to reveal their disappointment too much, but they explain to you in the next half hour why it's a stupid experiment, why it'll never work, and if it does, it'll be uninterpretable. Okay? So, you're pretty depressed. You leave the office, but if you're a good student, I'll tell you, after a couple of days, a couple of hours, you'll think, boy, John is losing it. PI, me, right? He's just, man, he's really lost it. Whatever. I'm going to do the experiment, and I'll tell you, that's right. The whole point of being a scientist is to think independently. That's what we're trying to get out of you guys, and the best students, so where's the slide? Yeah, the best students, they're pain. I tried. This is my answer to what is the funniest image you can find if you look for pain in the ass on the internet. This is what I found, right? So the best students are like this. They're a real pain in the ass. They really are. They will not listen to anything you tell them, right? Because they have their own ideas, and that's what you want. Right? And that's what you guys should strive for. You want to think independently. That's the whole point of doing science. That's the fun of it. Thinking independently. And I'm not telling you just to ignore what Soren or I have to tell you because, at the end of the day, we do know something. So, you can't find bin Laden in the airport with a sign. That's probably not going to work, right? But, some discoveries, many discoveries are made because the student did the experiment that wouldn't work, right? And I've had people come up to after this talk, you wouldn't believe it, but my whole career, I got a job because I did the experiment the boss said wouldn't work, and it worked. And I guarantee you, you keep doing this, you will have the great experience one day of walking into the boss's office with a notebook open to the experiment that wouldn't work, and you come in with a big smile, and you say, hey, you want to see the experiment that you told me would never work, or you don't want to see it, right? And if they're not psychotic, they're going to want to see it. And they're going to be so proud of you, right? Among other things, that you didn't listen to them, actually. Because we realize that. We realize the good students won't listen to you. Okay, and I'll tell you a secret. The PI has no idea what you're doing during the day. I mean, none. They really don't know what you do. When I walk in the lab, first of all, I've done this experiment all over the world. Most labs you walk into are empty. Anywhere in the world, at any time of the day. You walk into the lab, it could be 1 o'clock in the afternoon, 11 in the morning, they're empty. Okay, I don't know where people are. Everyone wants more space, but the evidence is actually there's never anybody in the lab. So, hey, I walk out in my lab, if there are people there, I'm pretty pleased, actually, right? And if they're not surfing the internet and they are holding a pipette or doing something that looks like work, I'm really, really happy. I mean, just delighted, actually, right? So here's the deal. I mean, I don't know what you do all day. So if I tell you don't do this experiment because it's stupid, I don't know that you've done it or not. And the 9 out of 10 times it doesn't work, don't tell me. I mean, really. I don't want to know, actually. Just show me the stuff that works or where I can help you because it didn't work. I don't need to know the failures. So the secret is, just do it. You don't tell the boss if it doesn't work. Put it in your notebook. Whatever. Think independently, right? That's what we're trying to do. All right, so how to make discoveries. It's useful to work on something interesting or important, and this may sound stupid, but there are some people who are afraid to work on something interesting or important because they think that, other people are doing it. Yeah, okay, they are. But still, it's really no harder than working on something uninteresting or unimportant. Avoid following the herd. You've heard that. Try to do that. Take advantage of your surroundings. Look around. What do you got that gives you an advantage over other people? I'm into stone. There's a hell of a lot of it around. If you're put 2 and 2 together. If you're next to a lab that's the best in a certain thing and it's never been applied to your field, do that. If it's a technique where they only know how to do it in Albania, right, don't do that. Right? Figure out what can you do to apply to your problem that will give you an advantage. You're eventually going to have to decide, do I want to do basic research, do I want to do applied research? Right? There's a huge push now from NIH, particularly into applied research. I would urge you not to underestimate the value of basic research. It is always interesting, and the problem is the importance often takes years to reveal. But I'll tell you something. Smart people who work hard, who do basic research, will always find something interesting. Always. Never fails. Guaranteed. The problem is, what's it going to be? You don't know. It's the nature of basic research. Applied research is always important, at least to who's ever footing the bill. The problem is that it's sometimes interesting, and I would argue it's very, very rarely interesting. So many of you will wind up at companies, and if you do so, it's a good thing. I mean, companies do important work. They bring drugs to market. We need them, but if you go to work for a company, go in with your eyes open. And companies exist for one reason: to make money. If they don't make money, there is no company. So for goodness sakes, get Hep Schwartz. We're not trying to do away with the common cold, and they're not, particularly these days. Right, so if you go to a company, realize that you are there as one of their employees to make money. You could be doing the best science in the world. If they make a decision that has nothing to do with making money, even the wrong decision, you're no longer doing that science. You're doing something else if they haven't fired you. Okay? If you try to do something practical, the odds are you will not succeed, because very, very few things make it into the clinic. It's just the way it goes. So all of that work will go down the drain, basically. You often don't learn anything interesting. Right? So you could tell, and I'm trying to present the Bill O'Reilly point of view here. I'm pushing you to thinking about doing basic research, which is very, very important. Okay, you do an experiment, you get a result. Interpreting your data is crucial. Think out of the box. Okay? It's an amazing thing when you do an experiment. You can think about the data and the experiment in a completely different way than when before you did the experiment. I don't know why it's true, but it's just true. So, you get the data, now try to get rid of all your preconceived notions and think, what would make this a Nature paper, science paper? What is the most interesting thing this could be? Many people do the opposite. They think, what's the most boring thing could this be? Don't do that. Think, what's the most interesting thing? Now, most of the time, it won't be that thing, but sometimes it will. People miss discoveries because they just haven't thought about it enough. Not only that, it's an excellent creative exercise. The whole point of doing science, the fun of it, is creativity. I think that's being beaten out of you guys. I think you're so worried about getting things right and doing things so carefully that you're losing the fun of science, which is creativity. It's not encouraged by the grant system, where basically they encourage people to do what everyone else is doing. Right? Try to think out of that box. Okay, case in point, here's a woman who lost her dog. Could be a cat, right? Now, the standard, the in-the-box answer is, dogs in the neighborhood, put up a sign. The woman had thought out of the box. Be sitting on the dog. That could be one dog whose life was saved. Okay, again, think big, right? It's a great thing we have as Americans. We're not afraid to think the impossible. Where was this guy 2 years ago? Oh my God. He's going to be president of the United States? People would ridicule that. The idea in Europe that someone like this could go to be the head of a country, I mean, it's just unthinkable. It's our greatest strength as Americans, actually, is this crazy optimism, which you need in science as well. You have these crazy ideas. Think big. Have big ideas, big concepts. We're not just going to be the 12th person to figure out the 5th alanine in HSP70, how it's working. Bigger palette there. How does proteins fold? How do cells work? Right? Big picture, which is, again, something you're not being trained in. You're getting narrower and narrower and narrower training these days. We're focusing on minutiae. Okay, so you've done everything I've told you, right? You've done everything right. Thought big, thought out of the box, cross-pollinated. You made this great discovery. You figured out gravity, right? You're Isaac Newton. And then you think, who am I? This lowly individual to make this discovery. I can't possibly be important enough. This happens. I've seen it happen in my own lab. People make great discoveries and they think, well, must be something wrong. Can't be me. You can't have this attitude, right? This has got to be your attitude, right? Really, I'm serious. You got to be the Pope. You got to be the world's expert. You got to think in your own mind, man, I can make a big discovery, because you can. It's the beauty of biology in particular. The systems are so detailed that you better be the world's expert when you're defending your thesis. You start off naive, you make the great experiment, and then you're doing all the reading. You're going to be the world's expert in what you do. You should never fear giving a talk or your thesis defense, because there's no one out there who knows more about it than you do. And it should be true as well. Okay, you got to do all the work. It's the hard thing about science. You got to get all these skills, all the experiments, all the reading. You have to do this yourself. Right? People aren't going to come and sprinkle fairy dust on you at some point in your career where magically you can now think or speak or read. Right? You got to do this right from the beginning. And I'll tell you, if you're thinking about basic research, if you don't think you're capable of making a significant discovery, don't do it. You're wasting your time and everybody else's. And I'm not telling you not to do it. Just have an attitude that you can make an important discovery. Okay, so you're working, you make a discovery, but it's not what you started out to do, right? So it wasn't your job description. So it's okay to get sidetracked, if it's something really interesting. And that's not such an easy thing to decide how interesting it is, but eventually your most important discoveries are probably going to be serendipitous, right? What is serendipity? It's a word that basically means you're finding something better than what you were looking for. Okay? And the key part is it's not luck. Takes wisdom. The key word here is sagacity, which means, for non-English speakers, insight, wisdom, sagacity. So you're lucky, but you're smart enough to know it. Right? So looking for a needle in the haystack and finding the farmer's daughter. That's according to Julius Conroe. Perfect definition of serendipity. So it's not this. That's Dr. Arnold Moore. He's conducting an experiment to test the theory that most great scientific discoveries were hit on by accident. Not quite that way. So how to be lucky? Well, this is who? Who's this? Louis Pasteur, right? Chance favors the prepared mind. So yeah. So this is the ultimate sagacity. If you don't know about Louis Pasteur, you should, because he was an amazing scientist. Let's see if I have it here. Let's see. I keep changing it. Yeah. So if you don't know about Pasteur, you should, actually. He started biology. He started biochemistry. There are a couple of books I'd recommend. One is The Microbe Hunters. It's a book from the 20s. It's a bit dated, but very good book. Inspirational. Starts with Leeuwenhoek, who invented the microscope. Moves on to Pasteur. Ends around 1900. Very good book. And then there's this great novel by Sinclair Lewis, one of the few American Nobel laureates in literature. And not a great writer, actually, but this was a good book. This inspired many generations of scientists, including me, to go into science. It's also a movie. You can rent it with Ronald Colman, as you can see. But it's actually a pretty good book, and it's based on the early years at the Rockefeller Institute. You won't necessarily know that you've made a great discovery. The meaning of discoveries are often hidden and take years to appreciate. Don't ever forget your unexplained results, because I'm still going back to my notes from 30 years ago, actually, and working on things, phenomena that I discovered then and never could figure out. So write them down. Don't trust your computer. Put them on a Post-it note. Move them from job to job. We made this discovery. Sooner or later, you'll be able to put the pieces together, and this could be a tremendous impact on your field. Here's a pet peeve, 2 P's, never use the P word. This is Einstein again. No amount of experimentation can ever prove me right. A single experiment can prove me wrong. I would even argue with Einstein. The one proving him wrong itself may not be proof, right? So never use the P word. P. We don't prove anything in science, right? The best we can prove is that observations are statistically likely to be accurate. Yes, if you're thinking quickly, I will agree that a dead mouse is a dead mouse, but that's about it. You can prove that. Nature is essentially unknowable in any definite way. These are not things that I spent my time thinking about when I was 25 years old, but I wish I had a little bit, actually. Would have made things probably a little bit more enjoyable. Interpretations are always subject to modification, and they will eventually be modified. Discussions can't be too speculative. It's a comment you often get back. The discussion of the paper is too speculative. Come on, who cares? You're supposed to speculate. That's the whole point. If it's wrong, it's wrong. Who cares? And I would urge you to go back to the very, very first issue of Nature. Okay, first issue, volume 1, page 1. You can get this online now. Nature is online. There's these aphorisms by Goethe, as recounted by T.H. Huxley, who's a very famous biologist. And I won't read this to you, but just read this essay. I came across this one night. I was at a meeting at Oxford. They have these meetings at these old colleges, and was in the basement like at 1 in the morning, was just looking at the old natures, and I opened number one, just to have fun. And man, I was just about crying reading this, because he just got it dead on about how unknowable nature is. It's something worth thinking about a little bit. I don't want you to go off the philosophical deep end, right? But just a little bit. At the end of the day, scientists must be professional skeptics, right? And it's easy to be skeptical about other people's work. Most people have no problem with that. But always question your own assumptions. Nobody knows the flaws in your work like you do. It's your job to disprove your most cherished models and ideas. That's what our job as scientists is. You can't fool nature. Okay, more practical. How to succeed in your lab. If you're just starting out in a lab, try to pick a project where you can do lots of experiments. Avoid single technique-based projects, particularly as a graduate student. These are awful, like making a transgenic animal or using mass spec to do something. You don't want to do that. Okay, why? Because you need to learn to design and interpret experiments. That's your single most important skill as an experimental biologist. Learning to design and interpret experiments. And the more you do, the better. Right? You also need to be obsessed with controls and develop control creativity. This is not obvious what the control is. That's one thing you get better at your whole life. This is why when you go in and talk to your boss, they can tell you the 6 controls you haven't thought of. It's not because they're smarter than you are. That's because they've seen a lot more experiments in their life. And controls are not just the control. Typically, they're the most important part of the experiment. You won't even learn what a control is if you're trying to make a transgenic animal. There is no control, right? You got to do experiments, experiments, experiments. The more, the better. Even so, the essential control will typically occur to you only after you see the data. Sometimes only after you give the talk and someone points it out to you. Or even worse, once you've submitted the paper. This happens all the time. The referee says, why don't you, you need to do this. And you go, oh, Christ. Man, that's right. The devil of experimental science is in the details. Well, on that slide, so what the details? Know every step of the assay. Know what you're doing. Have an idea of how the machine works. Know your reagents. Just because the tube says it's something doesn't mean that it is that thing. They could have put the wrong antibody in the tube. Maybe it cross-reacts, right? The whole time you're questioning. You're not taking anything for granted. Every step of every experiment, you should be thinking how you can do it better. It's the beauty of doing experiments. Every time you do it, you can do it a little bit better. You get better and better and better and better at it. Right? Yes. All right. What's the point of this slide? Man, it ain't so hard being a scientist. This is when Bush came and visited the Vaccine Research Center. The point here is that you should look at the cells. Right? If you're doing cell-based research, which most of you are if you're biologists, look at the goddamn cells. And my point is, if George Bush can look at the cells, you can look at the cells. Many biochemical discoveries were made probably based on using dead cells because the person never looked at the cells to make sure they were alive and happy. Not only that, you can make discoveries looking at the cells during an assay. It frequently takes a few seconds to put them on a cover slip and look at them. Because things happen to cells. Maybe they'll clump together. It's all sorts of things. If you're doing cell-based biology, always try to look at the cells. Microscopy is a crucial element of biology. And if there's a way to work microscopy into your project that you aren't using, I would encourage you to do it. There is nothing like, first of all, it's the most beautiful thing you'll ever do. And second, it's what biology is all about. It's about cells. No matter what you're doing, it's about cells. Learn what cells are. Right? You start a project, don't put all your eggs in one basket. What does that mean? Start with a pilot experiment and gradually make it bigger and bigger and bigger. Start small. Every time you do it, you'll do it a little bit better. It's also extremely depressing to start off with a huge experiment that fails. Okay? Start small and get bigger and bigger. Statistics are important, but don't be blinded by them. They're only as good as the assumptions they rely on. The assumptions can be, and they frequently are, wrong. Just because two values are statistically significantly different doesn't mean anything. They can be different because these 4 values are from this part of the 96-well plate, and these 4 were from this part of the 96-well plate. Yet the p-values are less than 0.00001. Big deal. Don't be blinded by statistics, right? So your generation is much more adept with statistics than mine is, but you guys are often blinded by them. Rather than do multiple experiments and best yet, different experiments that reach the same conclusion, you're looking for those perfect error bars. Now, I'm not telling you it's not important, but don't be blinded by it. Keep a good notebook. As I told you, I'm going back 30 years into my past. Man, I wish I kept a better notebook. My notes are not terrible, but they could have been better. Write down what's the point of the experiment. Why are you doing it? All the information, of course, you need to repeat the experiment. The weird post-it note observations, make a note, put them in yellow. And then force yourself to write what you conclude from the experiment. What did you learn from this experiment? It's easy to do a lot of work and not think about it. Make yourself think about it. Write it down. This is what I learned. Develop a thick skin. Embrace criticism. Okay, read Soren's essay. It's not personal. Typically, it's not. Remember, anything that leads to better science is good. Anything that hinders better science is bad. This is the whole point of doing science. Our mission is to find the truth. It's not to be nice to each other, okay? It's got nothing to do with it, or to honor our elders. Okay, this is why science in America is better than in societies where they honor the elderly people, like the head of the lab. The way a good lab runs is whoever has the best idea, that's what the lab does. In paternal type societies, the way the lab run is the oldest guy there tells everyone else what to do. And when he's wrong, everyone's afraid to tell him. That's not how good science works. Okay? So it's really a democracy of ideas in a good lab, and in America, that's typically the way it works. Work hard. I already told you this. 50 hours per week is usually what it takes. What else do you have to do? And I say that seriously. Do lots of experiments. Try to have more than one thing going. They're At the end of the day, though, there is no substitute for hard work. This is my effort versus productivity curve. I've plotted this for you. So here's productivity on an arbitrary scale versus hours spent in the lab per week. At 10 hours a week, you get nothing done. 20, nothing. 30, pretty much nothing. 40, we start to see something. 50, oh, good part of the curve. 60, better. At 70, you may want to move this over to the left a little bit. I'll have to be a little bit kind to you, but there's a joke here, so bear with me. 80, we're pretty much doing well. 90, uh-oh. 100, 120, person's insane. Okay? The point being, there's not a linear relationship between how much time you put in and what you get out of it. I don't know why the curve looks like this. It's probably shifted over to the left a little bit, but not much. One of the reasons it probably looks like this is that to be a good scientist, you have to be obsessive. Right? If you could be obsessive and work 40 hours a week, you'll probably do okay. But most people who are obsessive, they're going to work a lot harder because they're obsessive in the first place. The key part of science is most of the time your brain, even when you're not thinking about science, is thinking about science. Right? You know you're in a good spot when you wake up in the middle of the night and you have an idea for how an experiment could work or what it means. That means your subconscious is working on it, working on it, working on it. Right? And it's not necessarily comfortable to be in that zone. You're often fidgety, when the whole time your brain is thinking of science, but man, that's when the ideas connect. Because ideas typically come from nowhere. They just come out of nowhere. But often it's when you've been thinking and connecting dots from different fields. That's what you're looking for. Right? And again, hard thinking. You just can't let the PI do the thinking for you. You've got to be doing your thinking for yourself. Yes, you will go insane if you're just working. I don't know why it works. Daily exercise, a very good way to help you maintain sanity. Very good. Try to do something every day. Yewdell's first rule of exercise, 10 minutes is better than no minutes. Right? You're going to get a crappy workout, it's better than doing nothing. Ideally, you could fit something in. You walk to work, you ride a bike, something every day, right? That doesn't cost you too much time. This is not a problem in Europe, telling people to take their vacations, but some Americans, they don't even take vacations. I think it's very important to get away. And when you go away, really be away. Just leave, and I think at least 3 weeks and maybe 5 or 6 is okay. As long as when you're in the lab, you're really busting your ass. Okay? So take time off. Concentrate on your work. Don't get mired in lab politics or intrigues. Right? A lot of stuff goes on in the lab. It's a complete waste of your time to get involved in this. It really is. Okay? Yeah. Everybody feels like the little bird with the, on the bottom there. Everybody feels that way. Okay? Don't expect your PI to treat everybody in the lab identically. Don't expect it. It's not possible, actually. Why? Well, guess what? Your PI may not be a perfect person. You know what your PI is? It's you plus 20 or 30 years, basically, or 10. Right? It's just what you are. Are you perfect? No, you're not. Are scientists chosen for their psychological skills or their management skills? I mean, obviously not. We're picked to be PIs because we're good scientists. And most of us are terrible at managing people. You'll be just as terrible as your boss is. Okay? And even if we weren't, you guys are all different in the lab. You all should be treated differently. I can't treat you identically because you don't all need the same things. So even if I'm a perfect PI, which I'm not going to treat you all the same anyway. Right? So, in general, cut your PI some slack. Just assume they're trying to do the best they can. And cut everybody slack. And not just in the lab, but in life. Really. I mean, you can make yourself miserable by reacting to people. If you just sort of have the idea that, everyone's a good person, probably better than you, and you just misunderstood them, if they treated you in a way you're not happy with, that's a much better way to go through life. It's much better to be an ostrich in life, I'll tell you. And really, most problems solve themselves. And by reacting to problems, you usually make them worse. Okay, so take the high road with people. Don't have a chip on your shoulder. It really helps. Really helps. Everybody. Not just in science, no matter what you do. And if something happens in the lab and you get in an emotional state, make yourself slow down, right? Keep your mouth shut. Don't just immediately say the first thing that occurs to you. In 2 seconds, you can destroy a relationship that took years to build. You can lose a friend for life just because you didn't think, because the person will never forget. Okay, don't do it. What's there to gain for you? If you really don't like the person, decide later. I don't want anything to do with them. Not right there. What's to gain? Nothing. Right? Keep your mouth shut. Wait until you're calm before even starting to make a decision. Wait. 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 Things look completely differently with time. Right? Many problems, as I said before, will go away. You don't have to deal with them. But other problems that won't go away, you'll make a much better decision if you wait as long as you can before making the decision. I'm not telling you to put everything off. That's not a good way to run your life either. Right? But just wait as long as you can. Try to step away from it. It's amazing. You know, you can see this particularly when papers get rejected, for example. You see the rejection, you're very emotional. You think, oh man, that referee's a complete idiot. They really hate me, and they're ridiculous. And then years later, you go back and you read the comments. You go, oh, Christ. Man, they were completely right. You know, my God. I'm telling you, that's true with most of the decisions in your life. Things look differently with time. Okay, and this is a hard and fast rule. Never, ever, 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 ever write an emotional email. Guaranteed that this is what will happen to you if you do, right? Your email will come back and bite you in the ass. So whenever you send an email, just assume you are sending it for perpetuity to everybody in the world, because you might as well be. Okay, so never say something in an email, ever, 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 particularly anything negative, ever. If you got a problem with a person and you have to deal with it verbally, ideally in person. But if you write it in an email, it is never in doubt. You know, I'm telling you not to fight with people, but at least if it's verbal, the memories aren't so good. You know, they won't remember exactly what you said. Oh, we had a misunderstanding. Maybe they'll remember. If you write it down, man, there it is. And they may even come and like you at some point. And then they come across that email, like, oh, Christ, what a horrible person. Okay. So this is really meant more as a joke than anything else, but can you guess what this is? Take Ben's advice. Yeah. Unless absolutely necessary, avoid lab romances, right? So, yeah, I know, you're thinking, man, this guy, what a jerk. He just spent the last hour telling me how hard I have to work, you know, and I never can leave the lab, and let's face it, most mice don't date, you know, so who am I supposed to meet in life? So the odds are you will wind up with a scientist, you know, it's odds. But just try to make sure they're as far away from your working place as possible, because frequently what leads to Fidel Castro are romances in labs, and ideally they would wind up with marriage and children, but they typically don't. They wind up breaking up, and the worst thing is to be in the same bay as someone you've just broken up with, and, you know, so just try to avoid it if possible. Okay, MD, Ph.D., we're going to skip all this because none of you are MD, Ph.D.s. I was. Yeah, commit. That's a good slide. Yeah. Useful things I learned in medical school, so the good jokes here. Hey, you like these actually as PhDs, right? Yeah. Yeah. All these are true actually. Foxtrot. Don't ever go to the doctor unless you're really sick, okay? Really. And then go. But wait. Yeah. Sorry for this. Sometimes they're MD PhDs. Okay, so this is true for you guys too. Take responsibility for your own future and happiness. Develop a career plan. You don't have to follow it, but have an idea of what you'd like to be. You know, this you don't need. It's for MDs. This is sort of true. You know, achieving to please others ultimately leads to dissatisfaction. Don't do it for your parents, what they expect of you. You've got to do it for yourself. It's a little bit selfish, I know, but you won't be happy otherwise. You know, I'm giving you advice. You can seek advice. End of the day, you got to decide. And don't blame me because you took my advice. I'm just, as I told you in the beginning, advice is good. I've profited enormously in my career from talking to older people. You know, but it's not all perfect for you. You have to decide what's good advice, what's bad advice. The main thing is to get you to think about it. How to find the perfect PhD advisor. Anybody still looking for a lab? A few people, right? So wouldn't we all, everyone wants to be the lamb, right? And having Jesus hold us. I love that slide. You know, this isn't such a problem at Brown. The labs tend to be small. Harvard, big problem. Small labs, I think, provide a better training environment than large labs. Best thing is to find a rising star, be their first student. Requires luck. Talk to the other students. What's a good lab? The most famous people are not necessarily the best trainers. It doesn't really matter what you produce as a student, okay? It doesn't. You got to learn how to do the science. That's what matters. Okay, I don't know how big a problem this is here. You know, it's good to get out as soon as you can. You don't need 5 cell papers to get your Ph.D. 3 will do it. Joke. Yeah. Again, what do you need to learn? Not to fear the unknown. That's what you get from Ph.D. training. You have the attitude, whatever technique I need to learn, I can learn it. I know how to design, perform, and interpret experiments. I know how to write coherently and succinctly. You have to learn how to write, or there is no career for you, because no one will give you money. No one will accept your papers. You have to learn how to write. And if you prolong your Ph.D., typically it's just for your boss's benefit. You're the cheapest labor they will ever find. Public speaking, essential. Practice whenever you get the chance. Go to meetings, speak up, ask questions. You know, the young people usually have the best ideas. Don't be afraid. Attend conferences, and when you do, the talks are the least important part of the meeting, actually. Most important part, meeting people. Forming relationships, collaborations, that's your goal. At the end of the day, we have an important role to play in society and the political process. It's incumbent on us to preach the gospel of the scientific method. You are the priests. Tell your family members, your friends, how important the scientific method is. Right? When you have kids, get into the school, show them that science is fun, that we're not nerds, all of us, you know, that it's a good career, that we enjoy ourselves. And at the end of the day, I have to apologize to you guys, because my generation has done a very, very bad job in making science a attractive career. We have to do better than this. We now have a traditional financial sacrifice, which is insane, basically. The average American, this was before the crash, I don't know what the number is now, but you know, until a few years ago, the average American bought their first house at age 31. 31. I just saw that the average starting salary for Princeton graduates in the workforce, $56,000 a year. Okay, Ivy League school, let them go to Wall Street. Average starting salary for college graduates, something in the 40s. Public school teachers in Montgomery County, Maryland make $45,000. Right, you guys spend 6 years in graduate school. You're going to be lucky to crack $40,000 as a postdoc. This is insane. I don't get this. Oh, you're still training. That's just bullshit. It's a convenient excuse to pay you as little money as we can. This is crazy. You're doing the most important job in society. You're working your ass off. You're talented to begin with. And the most we can pay you is less than an elementary school teacher with no graduate training? And this is acceptable? What planet is this? What country is this?
So I have a question for you. Who decides that?
Well, we'll talk about that at the end. Yeah, that's a good question. You're right. Who decides it? I do. He does. He does. Scientists do. It's not NIH. We decide it. Right? We haven't been good stewards. I think we need to completely rethink the current system of laboratory research. We're exploiting you guys. I apologize. It's ridiculous that training lasts until age 38, which is the average age that assistant professors start. Average age for getting your first R01, which is the main research grant, 43. 43. I was 30. What's changed? Nothing, really. You guys aren't any stupider. Oh, there's more to learn. That's crap. So 2050, you'll be 114, because there's so much more to learn before you get your first R01. Oh, come on. That's an excuse? It's just convenient excuses, right? It's a convenient excuse for underpaying the most productive members of the lab. And it's stark. We don't really have graduate students. We have postdocs. And we'll pay a postdoc half of what we pay a technician, even though the postdoc is typically at least twice as productive. Oh, but you're training. It's ridiculous, okay? And it's got to change. And, you know, in the end of the day, the problem is there's just too many of you. That's the problem. We'd be much better off having half the people and treating you twice as well. That's, in the end, the solution. We have to control the numbers of scientists. It has to be done. We get more money, we get more graduate students, we get more postdocs. Ironically, we wind up with less money. The doubling of the budget wound up as a disaster for NIH. And who did this? Did Congress do it? No. Scientists did it. Yeah, so who's the enemy? It's us. Scientists dictate the system. I was involved 10 years ago in increasing postdoc salaries. I was fighting for postdoc salaries. And I'll tell you, the problem was not the government. And I say this not as a government employee, which I am, but that was not the problem. The problem was the scientific community. Everybody wants the money for R01s. Nobody's willing to pay for trainees. I have a friend who's chairman, used to be chairman of the microbe department at North Carolina. who wanted to just raise the salaries of postdocs there, because departments can do that if they want. And take, you know, common money and pay everybody. What he said was, you know, John, you wouldn't believe it. 90% of the faculty are like McDonald's owners. They just want to pay people as little as they can. If they could pay people $3 an hour, they would. That's the problem. Scientists are the problem. You guys will be the problem once you have your own labs. Scientists dictate how science is performed and things we really need to consider in the future. What's the optimal lab setup? What's the optimal size of a lab? Who should be doing the research? What's the optimal method of funding research? Is it the contract grant system, the R01 system, the program project system? Is this the best way to fund research? Right? So these are questions we're going to have to examine, and you know, like many things, your generation's going to have to fix this. The system has gotten worse and worse and worse. Sooner or later, we're getting to the point where it just won't work. We won't get good people. We won't get any people to do science. We'll have to come up with a new system. The good news is, experimentally, it's never been a better time to be a life scientist. I mean, ever. The things you guys are going to discover just going to blow us away. Right? We know so little about biology. So little. So that's the good news. One more thing. When you're looking to do postdoc or tenure track position, you couldn't pick a better place than NIH. Very nicely located. Not so far from downtown Washington, which is an interesting city these days. It used to be that NIH had really crappy labs, very old labs. We always had a lot of money, but the space was bad. Not anymore. Last 10 years, 15 years, everything's been renovated or rebuilt. And, you know, just remind you that NIH stands for really the best that the government has to offer. This is particularly for foreigners, particularly during the Bush era when America was viewed as this terrible, terrible thing. And just like to point out to people that biomedical research, government funding of it, was basically an American invention. And the U.S. government still, by far, funds the most research in the world. And at the end of the day, who benefits? Every human being alive. So the government, and NIH in particular, stands for, I think, the very best of America. And I am extremely proud to be part of the federal government. It's a great organization to work for. I encourage you to think about that as a future career, and I will end there, and we can talk for as long as you'd like. Huh? My Yankee montage? Okay, I'm sorry. I should have realized, you know, it's going to be a den of Red Sox fans. So I apologize. Oh, Twins. Oh, okay. The rare Providence Twin fan. Okay. You know, you can take the boy out of New York, but you can't take the New York out of the boy. You know what I'm saying. Okay, so what?
So one question I have is, you're saying, if I understand you correctly, you're saying part of the reason the postdoc have been so low is because there were too many postdocs and there were too many grad students. So,
yeah.
So do you think like grad programs need to be more selective and restrict the number of grad students?
I do. Yeah, I mean, yeah, so how do we reduce the number of scientists? Do graduate student programs have to be more selective? I think they do. I mean, you can look around at any graduate program in the country, the best places, the very best places, and everybody knows that, you know, a certain percentage of the students, sometimes very large, shouldn't be there. Now, it gets very tricky because, and you know, at the end of the day, it's very hard to pick out on test scores or objective criteria who the best scientists are going to be. This is true. So sometimes the best kids, you know, they weren't that engaged in college, or their native intelligence for doing experimental work or computational work is not clear. So that's why people say, you know, I've talked to people at graduate schools, they go, yeah, well, that, on paper that's good, but really we need to, you know, sort through a lot of kids to find the good ones. So I'm not telling you the answers to any of this are going to be easy. You know, but if we mandated, for example, that that postdocs had to be paid $80,000 a year, they had to be, there'd be less of them. I can guarantee you. Right? And, you know, one of the reasons, so if you look at the demographics, number of American kids going into getting PhDs in biology, the absolute number has basically been constant for 30 years. The increase has come almost completely from foreigners. Now, I am not a xenophobe in the least bit. I think one of the great parts of America is the fact that people come from all over the world to settle here. And we are able to filter from the best people in the world, and the best people come here. So this has been a very good immigration policy for us. On the other hand, the fact that foreigners are willing to come in and work for whatever we will pay them in science has made this a much more difficult career for Americans. If you said from the beginning that no foreigners could come and be graduate students or postdocs, there is a demand there to have students and postdocs. If nothing else to do the work, Americans would be making a lot more. It would be a better career. I'm not advocating necessarily shutting the, making it difficult to emigrate to be a scientist. But this is a factor, actually. So I don't know what the answer is in the end. Right? The problem is that we just keep bringing more and more people in. And they'll take whatever we pay them. Right? And it's not really a free market. The government sets the pay.
What do you think about the actual postdoc system?
I'm of mixed mind. I think if we paid you well, I would be much happier with it. I think there are some people who are ready, almost right out of graduate school, to work independently. Now, I think one of the lamentable trends as well, and probably because people are getting older, is what typically happens today is you get your own group, and immediately you stop working in the lab because you have a number of people you have to supervise. It didn't used to be that way. It used to be you would start out, frequently you could get a job straight out of graduate school, and you would work with a technician for a while, right? And groups were smaller, and they would get bigger very gradually. So I would advocate a return to more of that kind of a system. At the same time, not everybody is ready straight out of graduate school to run their own labs. And the relationship between a mentor and a postdoc can be very, very productive if in the learning process, changing fields. This can be very, very good. I mean, we've had a few people, we have only postdocs in our lab, and a few. With many people, we were able to do science that neither of us could do individually. So that works really well. If we were paying you as a professional right from the start, I think that would be an okay system. You're making $80,000, $100,000 a year as a postdoc. Okay. And then eventually you'll get your own group, the very good people will do that. So I think we just have to rethink the whole system. I think these laboratories that are enormous are ridiculous. Once you get beyond 20 people, there's no way the PI can keep track of what's going on. It's just not possible. Right? So in general, groups should be smaller. That would solve some of the problem right there.
Right, so let's say we increase the pay for every postdoc to $80,000. Where's that money going to come from?
There'll be less, right, you can fund less research. The enterprise will have to get smaller. But we'd be better off doing that.
Now, would that be, do you think that would be better off for American science?
Well, particularly if you could keep the best people, absolutely. There's a lot of mediocre people doing science, to be honest. A lot of mediocre people. A lot of people doing it a lot of the science today is just, there's a real tendency to focus on the minutiae and not to make new paradigms. Right? Now, maybe that's inevitable in any system. I know that. But we have a lot of I don't want to sound like an arrogant asshole here, which I risk doing. But my own opinion, there's a lot of very mediocre minds doing science. It's my opinion. Okay? And boy, if you can get rid of them, there'd be no cost. The problem is that the people who get the money are typically good at getting the money. And if you got rid of people, to the extent you're going to get rid of them, you'll lose a lot of your best minds who are not that good at that. So it's very tricky. I just know that what we have now is not fair. It's ridiculous, is what it is. Ridiculous. 6 years in graduate school to make less than you would have made doing anything else out of college? How does that make sense? And other fields, they pay their postdocs way more than we do. Biomedical research is probably at the bottom of what a Ph.D. makes in this country. Bottom. It's not right. It's not a good policy. It's dumb. Aside from being unfair.
In computer science is like 50.
Yeah, or more. Yeah, yeah. I mean, I know at NIST it's in the 60s. Yeah, it's the same government.
But aren't departments setting up those rules?
Not really. And they're pretty much based on the NIH training grants system. So the NIH is basically setting those salaries, but they're setting them at what people want.
So there is flexibility in the NIH guidelines.
No, but NIH is just basically giving. NIH is basically doing what the scientists are asking for. There's a lot of dialogue between.
The scientist as a whole.
Well, it's even more official than that. I mean, so the way that budgets get set is that the big scientific organizations, like AAAS, like FASEB, particularly FASEB, every year they put a request into Congress. And that's, to a large extent, what gets done, actually. Congress is really trying to work, and not even so much the administration, but Congress, who actually writes the funding bills. They are really trying to work with the scientific societies to give them what they're asking for. I know this because, again, when I was involved in the in increasing, there was a big bump in postdoc salaries that happened around 2002, and I was involved in that. I saw what it took. And basically what it took was convincing the other scientists that this is something they should ask for. And what I found was that in the professional people who deal with NIH, for example, on the Hill, in the societies themselves, they're very sympathetic to these issues, very sympathetic. The problem is not with the problem is not actually with the people who would implement it, it's with the people asking it. The problem is the people running the labs. Because they all say, oh my God, if I have to pay my postdocs $20,000 more a year, I won't be able to do this research, which is true. So the solution is we need to have less scientists, basically, or get more money. But the problem is whenever we get more money, we don't give it to you guys. We basically get more scientists. We hire more assistant professors. We make things worse in the end. It's this remarkable sort of cycle we've gotten into. NIH funds more money, deans get big ideas about buildings, holes appear in the ground, buildings get put up, more assistant professors get hired. We're worse off than when we started. So probably in the end, what nobody wants, but maybe it's the only way, is the government will have to decide, allocate the resources, which is frightening, right? I mean, we know, but if the government's paying for all the research anyway, maybe they should be doing that. I know centrally run economies are disasters. We all know that. But what we have now is not working. The free market, there isn't a free market in biomedical research. And what we have is not working. And the people suffering, it's not my generation, mostly. It's your generation. You guys are getting screwed.
It sounds like a pretty grim picture for staying in academia.
It does.
For example, speaking for myself, I have loans to pay off.
I know.
Going to a postdoc making $40,000 a year for the next 3 years.
It's ridiculous.
Paying a mortgage,
yes.
Paying school loans.
Yes.
So I'm basically paying to be a scientist.
I hear you. This is not fair. I agree with you.
Personally, tell you just, I am making now probably half as much as I do with a bachelor's. I worked in the industry for a while. And the more I learn about academia and the whole system, the less I want to stay in it.
It's not attractive. I know. Yeah, I feel a little bit bad because I'm pointing out these problems that I can't fix. I agree with you.
I'm sure it's nothing that all of us have already thought of at some point.
I'm just telling you, if you're going to go into science and you're thinking of academia as a career, factor all these things in. There's other ways to make a living. Right? And at the end of the day, the reason to do it is because you can't do without it. Sad but true. Right? And it's different than it was 30 years ago. Really different.
Well, if the economy improves,
it will. That'll happen.
Less wars that we need to fund, there will be more money for science.
Only if we fight for it. And again, we have a genius at where the money is, again, true, Soren, but these guys are still, every year they're getting screwed more. I mean, I'm sorry, but that is the truth. So I went to this National Academy meeting. This was 2001, 2000 now, year of 2000. National Academy of Science meeting on problems with postdocs, right? And they weren't quite as bad as they were today. So it was a meeting, 10 years ago. And somebody got up, summarized beautifully, one of the postdocs got up and summarized beautifully all the problems. Very eloquent. And she gave it, and everyone's going, yeah, that's true. She goes, well, what I'm reading to you is a summary of the report from 1988. So people have been aware of these issues for, 20, 30 years now, and nothing gets done. It gets worse and worse and worse.
Well, it sounds like we don't have much of a voice.
You don't. Some of you need to go into politics. I'm serious. It's an honorable profession, actually. Politics is very important. Very important. And that's how things get changed. Right? I mean, wouldn't it be great if you had people who were in Congress who had Ph.D.s? I mean, really. It's a different world. There are a few. And they're good advocates of science, but most of these guys, particularly in the House, I mean, they're idiots. They really are. I mean, no education, very poor. So we have to do better. We have to preach the gospel of the scientific method. Society depends on it. I mean, societies, there's no guarantee that a society lives forever. Roman Empire, we're way ahead of the rest of the world. Didn't last. I mean, no great empire lasts. And ours won't last forever either. But for sure, if we abandon the scientific method, right, and we don't push science, I mean, our life expectancy as a society drops precipitously. I mean, in this world, what's left for Americans to do anyway? I mean, really. And, in fact, the whole world, and right now what happens is whoever will work for the cheapest gets the jobs now, right? But that will end too. You'll go through every continent. Now it's Asia, then it'll be Africa. Eventually machines will be making everything. I mean, really, that's the trend. Right now, people are cheaper than machines, but they won't be forever. The technology, better. At the end of the day, societies that will be prosperous are the ones that are inventing everything. And we all know that. The politicians pay lip service to it. The trick is making them live it. You want science and technology, you're going to have to pay for it. This is a problem with America. Everyone wants things for free. And you guys, in a way, we're all complicit. Because we're letting them get it for free. We're letting them pay you half, at least half, at most, I should say, half of what you should be getting. Society is taking advantage of you. They really are. So, I know, what can one person do? Nothing. You can start to talk. You guys can start to organize. There are national postdoc associations. What would a nationwide postdoc strike do? Immediately nothing. That's the problem. And one of the problems is that why are you paid so low? Historically, I think it's because MDs run the system. And what they did was they grafted on this mistreatment of house staff, right, onto the lab system. Basically that's what they did. Because the house staff, they always were underpaid for how much work they were doing. They still are. But in medicine, the payoff always was, you got to be a doctor and you made a really good living. Those rules are changing too now. So that I think is the historic roots of the problem, but that still doesn't solve it in any way. We need to make it a better career. We really do. And university presidents, they need to raise their voices to this. So the faculty should be pushing the universities to do this. It's not easy, any of this. But if all the Ivy League presidents got together and said, boy, science is really important, and we're going to go to Congress and tell them this. I mean, this is how things get started. Right? And again, what can one person do? Well, you just never know. That's the beauty of this crazy American optimism. Sometimes one person starts something happening. So I would encourage you to be more active, in fixing these problems. Maybe that's the best message. And I would encourage you, when you get in positions of responsibility, to not think, oh man, it's bad for me, so screw the students. That's a terrible attitude. The attitude should be, if I was abused, I will make sure this never happens to anybody else. That's the attitude. Yeah, I don't know. It's rough, but I can't honestly give you advice and not point out what the career really is like. I can't. That's part of it. You got to look at it the way it is and not the way we wished it would be. Yeah.
So most of your talk's been directed at postdocs and grad students. I'm an undergrad. What do you have advice you have for me?
Well, you know, find what you love and do it. Still, that's my advice. You know, go to graduate school. Don't take any time after undergraduate. If you're really intent on being a scientist, go straight to graduate school.
Why?
Because the clock is ticking. Your life is only so long. You don't want to be 40 years old when you get to be an assistant professor. You want to get through as fast as you can. Try to pick a graduate school where they have, you know, where they tell you the average time to a degree is 4.5 years and not 8.5 years. Try to get through everything as fast as you can. Be as focused as you can. You know, I mean, at the same time, my own son took none of my advice. Spent 2 years doing things before he went to graduate school. Okay. You know, you decide what you want to do in your life. I'm just telling you, career-wise, the sooner you can do it, the better. Everything fast, fast, fast. Get through it. You know, we hired a guy before he was 30 to be a principal investigator. You could still get those jobs. And the one good news I'll tell you is if you're really good, I mean really good, you know, you're in the top 5 or 10% of your peer group, you will succeed. You know, you'll definitely get a chance to run your own group. Beyond that now, you know, I think eventually you'll succeed, but boy, right now, in terms of getting funding, it's really hard. Really hard. And so the key there is you've got to try to find a job at a place that will support you for a prolonged period, that will have faith in you, that will back you. Because right now is a very, very difficult time to start up a lab and a group.
Yeah. Just as a preface, I'm an undergrad as well, so my knowledge is relatively limited. But what kinds of career opportunities are there for PhDs in industry in this economy, in this climate?
I don't know what the unemployment rate is, and you know, whatever the climate is now, it'll be different 4 years from now, 5 years from now. So who knows? You know, I mean, you go to industry, you have a good living, you don't get rich. Salary-wise, unless you get into the business end, you probably do a little worse than if you went into academia and you're successful. It's not like there's riches in industry, unless you go to a startup and you know, and it makes it, which is not too typical. And the problem with going with industry is that, you know, I mean, basically to be an American these days is a tough job because things that used to be lifelong jobs are no longer lifelong jobs. And basically the key to being successful in the American economy is being flexible. The odds are you won't spend your whole career with one company like people used to do. You know, it's just, I don't know about American capitalism, but things have gotten harder and harder. My parents' generation, man, unless you were retarded, you had a middle-class existence. I mean, really. I mean, if you went to college, your life, you didn't have to do anything, basically. It was a very comfortable existence for everybody who had a college degree. My generation, not really. People now, you know, 50-year-old people, they're losing their jobs. Companies downsize or change directions. They fire 50-year-olds, 40-year-olds all the time now. There's zero loyalty that goes with employees. You know, they'll screw you in your pension plan if they can. And your generation, completely different again. I don't know the rules. They keep changing every generation. But, you know, things in America just, they really seem to get harder and harder each generation. They really do. You know, you guys starting out, much harder to find jobs. Everything about life in America has gotten more difficult. You know, the rich people get richer, true. But everybody else, you know, people have to work harder now. And the thing in America, there is no safety net. It's not like in Europe where there's someone, you know, you can't, you know, you can always live in Europe. U.S., you can be homeless. You cannot have health insurance. Now, you guys are going to inherit a society that you got a lot of fixing to do. It's not a very fair society. You know, we haven't, you know, my generation has not done a very good job. Politics has been a disaster. You know, since Reagan, basically. This guy who's lionized as this great president. I mean, to me, this is where the country started going downhill. It just became this dog-eat-dog country, where the only people who win this battle are the people who own the things. And I'm not a communist, believe me. But man, I mean, the average person in this country just gets screwed every which way. And your generation's going to have to deal with this. What do we want to be as a country? Soren says this healthcare issue, and I agree with him completely. It's a moral issue. It's not an economic issue. Rich country like this, and you have people who aren't treated? This is disgusting. In a Christian country, we have sort of the worst world with this religious stuff, right? We have to listen to all their crap, yet at the same time they're mean to everybody. I mean, at least if they're Christians, they should be generous and kind, right? But no, they want to tell me what to do as an atheist, but on top of that, they don't want to be real Christians, according to Christ anyway. I mean, it's the worst of all worlds with these people. I respect Christianity for what it is, but man, the way it's practiced and what this country has become. And to me, Obama, this is the first sign. Clinton was not great either. I mean, this is the first guy who's really started to turn this thing around. So this is your job in many ways. We can't do science unless society is a society that can support science. Right? And I'm sorry to be so philosophical here, but these are all problems that your generation's going to have to deal with. Many, many things in this country to fix. And the only thing I'll say is, America's filled with problems. The only thing is if you go other countries, they're worse. A few exceptions. I've been all over the world, and man, in many ways America's like a paradise compared to other countries. So this is human nature. It's always, never perfect. You got to have a positive attitude, though. That's for sure. If you got to have the attitude you can make things better. Even if it's not true. Still a very useful attitude. Optimism, very, very good American trait. And we're probably all crazy optimists just genetically. I mean, who in their right mind leaves a country to go to someplace else completely new? They come off the plane, or there used to be a boat with nothing, right? So I think there's a big genetic component to what America is. Many of us are only a few generations removed, or zero, from people who are just willing to say, boy, I will not stand this system. I'll go somewhere else where I don't know anybody. I have no job. I have nothing. I'm going to go there and we'll see what happens. That's a really good attitude. And we all inherit that attitude, both culturally and genetically. So, okay. I don't want to get you guys depressed too much. In the end of the day, things work out. I'll tell you that. Smart people, work hard. Somehow, one way or another, things work out.
Two things. One thing is that brown students always get all their jobs. Our experience is that they are extremely looked after. It's very competitive. At least our students, we see them. People appreciate what Ivy League school teach them. And secondly, I think it's about the next generation problem solving. I think technology will provide innovation that will change
everything.
Bottlenecks will be totally different problems.
That's right.
They will have totally different jobs that we even believe they are available today. And it's up to you to make some young blood, young thinking.
Absolutely.
Paradigm shift.
Yeah. Fix it. Plenty to do. Plenty to discover, plenty to do. Society's got a lot of things you guys can contribute to. And you don't all have to be scientists. I mean, most of you won't be in the end bench scientists. I mean, it's just the numbers game. Many of you will have other careers, which is, great. So, open mind as well. And if you got an opportunity, looks interesting, think about it, go for it. Doesn't work out, try something else. It's the beauty of America. You keep reinventing yourself. It's the one strength we still have. People give you a chance, give you a chance, give you a chance, give you a chance. You have people going to medical school when they're 40 years old, doing other things, right? So, good luck to everybody.